Welcome to the part 2 of the course, Methods of Fossil Preservation and Extraction. Fossils provide invaluable insights into the Earth's history, allowing geologists to reconstruct past environments, study ancient organisms, and understand the processes that have shaped our planet. However, the delicate nature of fossils requires careful preservation and extraction techniques to ensure their integrity and maximize the scientific knowledge gained. In this part of the course, we will explore the methods used for fossil preservation and extraction, the various fossilization processes, and the tools utilized by paleontologists. Fossilization is a complex process involving transforming organic remains into a preserved record of life from the past. Different types of fossilization can occur, depending on the environmental conditions and the composition of the organism. We are going to study 4 different classes. 1. Permineralization. 2. Replacement. 3. Carbonization. 4. Molds and casts. 1. Permineralization or petrification. This is the most common type of fossil preservation. It occurs when minerals gradually fill the pore spaces within the organism's tissues, creating a replica of the original structure. The minerals usually include silica, calcite, or pyrite, which act as cementing agents. Permineralization can preserve detailed cellular structures and even soft tissues. In this image, we can see a tree trunk have been replaced by silica, and the ring structure in the wood is clearly observable. 2. Replacement. Here we see an example of replacement. In this process, the original organic material is completely replaced by minerals. In the case we have here, the replacement is by pyrite. The minerals infiltrate the organism's tissues and gradually crystallize, replicating the original structure. Replacement fossils often appear as solid rock-like structures and can preserve fine details. 3. Carbonization. This is an example of carbonized fossils. In this case are fossils of plant leaves, specifically ferns. Carbonization occurs when an organism's organic material, such as plant leaves or insect wings, is compressed and heated, causing volatile elements to be expelled, leaving behind a carbon residue. This type of fossilization is common in plant fossils and can preserve delicate features in two-dimensional form. Molds and casts. In certain cases, the organic material may completely decay, leaving an impression or mold in the surrounding sediment. Minerals or other materials can then fill this mold, creating a cast that reproduces the shape of the original organism. Molds and casts are particularly useful when studying delicate or soft-bodied organisms. This is a fossil called Autoya. It is the remain of a soft-bodied worm, abundant in the Burgess Shale from Canada. The age of this fossil is approximately 508 million years old. Fossil extraction techniques. Once fossils are discovered, paleontologists employ various techniques to extract and preserve them for further study. These techniques minimize damage to the fossil and ensure its long-term stability and accessibility. 1. Field preparation. Field preparation involves careful excavation and removal of fossils from the surrounding rock or sediment. Tools such as brushes, dental picks, and small chisels delicately expose the fossil without causing damage. The surrounding matrix is often removed in stages, allowing the fossil to be extracted gradually. Once the fossil is extracted from the rock, is transported to the laboratory to be carefully prepared. With real paleontologists and learn what they do in real life. I want you to look carefully at what these paleontologists do. We will need to use that knowledge in the exercises after the movie. This movie is about a trip to the late Cretaceous, with Walter Stein, a real paleontologist. Visit to the Hell Creek Formation of South Dakota. The title is Hunting Dinosaur Fossils in South Dakota Hell Creek Formation.